Welcome to the debate. I want you to imagine walking into a corporate server room from the late 1990s.
Oh boy, I can practically smell the ozone and dust already.
Right, there are no neat modern racks. There are no color-coded, nicely labeled ports. Instead, you are just staring at this chaotic, floor-to-ceiling web of tangled wires.
The classic spaghetti cable nightmare.
Exactly, and if you need to plug in a single new machine, you have to manually trace one gray cable through a massive, dusty knot of identical gray cables.
And you're terrified the whole time.
Totally terrified because the stakes are incredibly high. I mean, if you pull the wrong one, a critical database across the building goes dark and, payroll stops.
Yeah, which is a quick way to lose your job.
Precisely. Now, if you've ever been afraid to change one line of code in an old software system, you know exactly what this feels like. We are facing a massive, industry-wide crisis in developer productivity right now.
We really are. It's becoming unsustainable.
According to a detailed analysis by CodeAura, engineering teams are trapped in what they call a productivity paradox. Developers are working harder and longer than ever, yet they are somehow delivering less.
Right, because they're spending drastically more time decoding those existing tangled legacy systems than they actually spend writing new code.
Exactly. So today, we are tackling the central question raised by this material. Does resolving the profound friction of legacy systems require implementing an AI-powered infrastructure layer to automate that understanding?
Or, on the flip side, does relying on an automated tool to decipher invisible complexities fundamentally erode the deep system mastery required for safe software engineering?
Well, my take on this is straightforward. I mean, human memory simply cannot scale to meet this problem. The structural friction of legacy code can only be solved by externalizing that knowledge into, automated system-aware AI infrastructure.
And I look at this from a completely different angle. While the friction is very real, attempting to abstract away the complex, tangled network of legacy code with AI-generated clarity risks creating a superficial understanding.
You don't think a clear dashboard helps?
I think it puts a clean dashboard over a fundamentally broken foundation, which, masks rather than cures the underlying systemic decay.
Okay, well, to really grasp the severity of this, we have to look at the sheer scale of the dysfunction the CodeAura material outlines. Low productivity in software teams rarely looks like people just sitting around doing nothing, right?
Oh, definitely not. They look incredibly busy.
Exactly. The developers are constantly engaged, their calendars are packed, yet the actual feature output is minimal because the environment is just structurally fighting against them. The text points out a staggering metric here.
The 17 hours?
Yes, developers can lose up to 17 hours a week just trying to understand the code base.
That's almost half of a developer's productive time.
Half evaporated into a purely archaeological discovery phase. I mean, we have to acknowledge that this is a structural failure. It is not a talent issue.
No, it's an environment issue.
Right. And the material notes that over 40% of legacy code in many enterprise environments is either entirely undocumented or poorly documented.
Which is a generous estimate, honestly. I've seen worse.
Yeah, I bet. So because of this gap, organizations rely on what we call tribal knowledge. They turn their senior engineers into human encyclopedias for every loosely defined, invisible connection in the code.
Which is exhausting for the senior engineers.
It is an unsustainable way to run a business. The only viable path forward, and the one the analysis shows high-performing teams taking, is utilizing systems like CodeAura to automatically generate documentation, map dependencies, and provide instant contextual answers.
So shifting the burden off human memory.
Exactly. It shifts the burden of understanding onto a robust, searchable infrastructure.
Look, I completely agree with your diagnosis of the symptoms. Legacy environments are absolutely riddled with undocumented dependencies.
They're a nightmare.
They are. And they cause an extreme amount of cognitive fatigue for the people working in them. I mean, we've all seen that one piece of code with a comment from 2014 that just says, "Do not touch or everything breaks."
Yes. And what do? We all just back away slowly.
Right. Anyone who has stared at a sprawling, decades-old codebase knows exactly the hesitation you described. However, I fundamentally challenge the material's proposed cure.
Really? The AI assistant?
Yeah. The idea of democratizing knowledge through an AI assistant deeply misunderstands the true nature of legacy complexity. You mentioned these loosely defined invisible dependencies earlier.
I did, yeah.
If an AI system scans that chaos and generates a beautifully formatted, transparent map, it is offering a false sense of security. The 17 hours the developers spend navigating backward through a codebase isn't merely friction waiting to be automated away by a machine.
Then what is it? Because it sounds like friction to me.
That time is the necessary crucible. It is the hard, manual process of tracing logic, where a developer actually builds a structural mental model of how a fragile, idiosyncratic system operates under stress.
Wait. I need to make sure I'm following your logic here. Are you suggesting that we should intentionally keep the system opaque just to force developers to eat their vegetables and learn it the hard way?
No, I wouldn't say.
Because the text explicitly frames the 17-hour discovery phase as unmeasured, wasted work that dominates the week. I mean, when a developer gets a task, they don't start building, they start hunting.
Well, hunting is part of the job.
But they're trying to figure out where the logic lives, what other systems are affected, and what unintended consequences a change might trigger. This shifts the entire engineering culture from proactive creation to reactive interpretation.
Okay, but I'm not saying we should artificially maintain opacity. I'm saying the opacity is inherent to the complexity of the domain. You can't put a simple interface on a fundamentally complex reality without losing vital resolution.
I'm not sure I agree it loses resolution, though.
Well, you are treating understanding as a binary data retrieval problem. You're assuming that knowing where a piece of code lives is the exact same thing as understanding how it functions within the broader ecosystem.
Okay, give me an example.
Think about how we navigate physical spaces. When you navigate a new city using a GPS, you never actually learn the streets.
You just follow the blue line.
Exactly. You just follow the blue line. If your phone dies, you're completely lost because you never built a spatial map in your own mind. Handing a developer a finished AI dependency map is the exact same thing. They passively consume the route.
But we aren't trying to teach cab drivers a city here. We're trying to deliver packages.
That's a dangerous way to look at software architecture.
Is it? If the goal is shipping features safely, why force them to learn the layout of a city that's constantly changing anyway? Let me push back on how you're framing the AI's capabilities, because we need to clarify what modern tools actually do.
All right, go ahead.
Older static analysis tools were dumb. They literally just search for exact text matches. It was like looking for a specific word in a giant library.
Right, grep searches.
Exactly. But semantic AI, which the Coda R material focuses on, understands the intent and the flow of the code. It recognizes that a variable named customer ID in the billing module logically connects to a generic user token in the authentication service.
Assuming the connection is logical in the first place.
Well, it's like having a librarian who has read every single book, knows every footnote, and can instantly draw a string on a corkboard showing how a character in book A influences a plot in book Z. Why wouldn't we use that?
I'm sorry, but I just don't buy that. Let me tell you why.
Okay, what?
The problem with the omniscient librarian analogy is that the librarian doesn't know the history of why the library was built that way. And that brings us to the core issue of who actually holds the context.
The senior engineers, usually.
Exactly. The text points out that in the absence of structured systems, people become the documentation. Senior engineers accumulate years of system knowledge. They know where the risks exist and what to avoid.
Right, tribal knowledge.
But I argue that this intuition is rarely explicitly coded into the syntax for an AI to read. If 40% of the code is undocumented, an automated tool attempting to generate documentation is doing a massive amount of guesswork based purely on legacy syntax.
It maps dependencies. It doesn't just guess.
But it will fundamentally miss the historical context. Let me give you a classic example. It won't know that a bizarre database query was written that way to prevent a highly specific race condition.
Oh, right.
You know, that nightmare scenario where two different parts of the system try to change the exact same piece of data at the exact same millisecond?
Yeah, those are brutal to debug.
And maybe this specific race condition only happens during a massive Black Friday traffic spike. The AI sees the workaround, flags it as inefficient, and suggests a cleaner path that accidentally resurrects a devastating bug that takes the site down.
I see your point, and, you're entirely right that bad AI documentation is worse than no documentation. A false sense of security is incredibly dangerous.
Exactly. It's a landmine.
But that assumes the AI is just taking a single static snapshot and making blind guesses. The text explicitly states that automated documentation systems evolve alongside the codebase,
Evolving bad guesses doesn't make them better guesses.
but it provides a continuously updated, contextually accurate reflection of the system as it changes. And honestly, I have to challenge this romanticization of the senior engineer as the ultimate flawless knowledge vault.
I'm not saying they're flawless.
But human memory is fallible. We have to look at the cognitive science behind this. I mean, short-term working memory can hold roughly 7 items at a time.
Sure, the magic number 7.
Yeah, but a modern enterprise legacy code base has tens of thousands of intersecting variables, microservices, and databases. The human brain just isn't designed to hold a 10,000-piece puzzle in active memory.
No, but it's designed to understand patterns.
Even so, the 17 hours developers lose every week isn't just lost time on a clock. It's a brutal biological tax on working memory. It's the cost of constant context switching. Centralizing expertise in people is a catastrophic single point of failure for a business.
It is a bottleneck, I'll give you that.
It leads to constant interruptions. Junior and mid-level developers wait hours or days for approvals. The senior engineers are pulled away from strategic initiatives just to answer questions like, hey, is it safe to change this module?
Which is why they get burnt out.
Exactly. This fragments their productivity, leads to cognitive fatigue, and ultimately causes team burnout and attrition. And when that senior engineer leaves, that highly specific historical context about the Black Friday race condition walks right out the door with them anyway.
That is a fair point. Brain drain is real.
We have to democratize this knowledge, so onboarding doesn't take months and progress doesn't halt when one person is out sick.
Look, I'm certainly not romanticizing burnout, and I agree that keeping knowledge siloed in one person's head is a massive vulnerability. If you're an engineering manager listening to this, your first instinct when dealing with legacy chaos is probably to say, let's just rewrite the whole system.
Oh, the famous burn it down and start over approach.
Right. But as we know, a from-scratch rewrite takes 2 years, freezes all your feature pipelines, and usually ends up creating just a second legacy system.
Always. It never works the way they want it to.
So I understand the temptation to reach for an AI tool to just manage the mess. But distributing flawed or shallow knowledge across a team via AI doesn't solve the vulnerability. It just scales the risk.
How does it scale the risk if everyone has the same map?
Because if the AI generates documentation that makes a complex, fragile legacy module look simple and clean, a junior developer is going to trust that documentation implicitly.
Well, they should trust the tools.
But they're going to proceed with a level of confidence that the underlying system does not actually warrant. The hesitation you mentioned earlier, the fear of touching untouchable code, is often a highly rational survival mechanism.
A survival mechanism?
Yes, it stops junior developers from bringing down the company.
But the material clearly identifies that fear-driven development as a symptom of a failing system. I mean, high-performing teams don't operate in fear.
They operate with respect for the complexity.
They prioritize understanding first. They invest in clarity before execution. And this perfectly bridges into how we actually build inside this maze once the AI maps it.
Okay, let's hear it.
If we trust the AI to map the chaos, shouldn't we trust it to help us pour the new concrete? The material outlines a clear shift to AI-assisted code generation. Once that understanding is established through the system map, we move to execution.
This is where things get really dicey.
Not if it's done right. By reducing the cognitive load of exploration, teams can use the AI to generate the scaffolding. You know, the repetitive, structural boilerplate code that just sets things up without adding unique logic.
Right, the tedious stuff.
Exactly. Because the AI is already context-aware of the system dependencies, developers produce code with better first-time accuracy. They aren't starting from a blank page. They are starting from an intelligent draft.
That is a compelling argument, but have you considered what actually happens when you combine rapid AI code generation with an inherently unstable foundation?
I mean, it speeds up the stabilization process.
Does it? What is technical debt really? It isn't just poorly formatted code. It's code that doesn't fit the underlying architectural paradigm of the system.
Sure.
The text itself warns that legacy systems punish speed and that small updates have unpredictable consequences. And you are suggesting we use an AI assistant to rapidly generate new code and scaffolding on top of this fragile base.
Because the AI understands the base.
But the developer doesn't. If developers no longer hold the system in their heads because the AI is doing the heavy lifting, they lose the capacity to critically evaluate the hundreds of lines of code the AI just generated.
They still review it.
They review it passively. They are rapidly scaffolding over dependencies they don't fully comprehend. You aren't curing the technical debt, you are just giving developers a power tool to accelerate the creation of new technical debt.
Oh, wow.
You're basically building a faster train on a track that is fundamentally broken.
Okay, that would be absolutely true if the AI was just blindly generating code in a vacuum, acting like an overeager autocomplete. But that ignores the specific workflow the material outlines.
Which is?
Visibility precedes the code generation. The transparent system map I mentioned earlier isn't just a static picture you look at once. It allows teams to simulate and understand how components interact before committing changes.
Simulation isn't reality, though.
It's better than manual guesswork. The developers aren't just blindly trusting the AI to write the code. They are using the AI's visualization tools to verify the safety of the change. It reduces the testing overhead because the developer can actually see the interaction diagrams.
So the AI draws the diagram and the AI writes the code.
The AI amplifies the developer's ability to problem solve. It doesn't replace their critical thinking. It gives them the concrete data they need to actually apply that critical thinking rather than wasting their mental energy trying to manually track a forgotten variable across 50 different files.
But the act of tracking that variable is the critical thinking.
How so? It's just search and find.
No, that manual process is how the brain categorizes and weighs the importance of different system components. When you hand a developer a finished map, they look at it passively. When they have to draw the map themselves, they deeply understand the terrain.
I just don't think we have the time for everyone to draw their own map.
But look at the productivity paradox we are discussing. It states that teams are working harder than ever but delivering less. I submit that if you deploy AI code generation without requiring deep manual system comprehension, your metrics might briefly look fantastic.
Which is what businesses want.
Sure, initially. You'll see more lines of code written, more features pushed to staging. But the system as a whole will become exponentially more brittle. The cost per feature might seem to drop initially, but the cost of the inevitable systemic outages will utterly dwarf those short-term savings.
That feels like a stretch.
You are creating a distributed factory of developers who don't truly understand what they are building.
Honestly, I find that view a bit overly pessimistic regarding the capabilities of modern infrastructure and, quite frankly, the adaptability of developers. The text explicitly compares the before and after states of teams adopting these AI-augmented workflows.
And the after is always magically better in the brochure?
It's backed by data. Without AI support, you have high rework, agonizingly slow onboarding, and isolated knowledge. With the AI-powered knowledge base, you have shared, searchable context and much better first-time accuracy.
Shared context is only good if the context is correct.
It notes a fascinating point, actually. In the old model, adding more developers to a legacy project just increases communication overhead and chaos. It actually slows the team down.
Yeah, the classic mythical man-month problem.
Exactly. But in the new model, because the knowledge is externalized and accessible, adding new team members actually increases delivery capacity. It makes scaling an engineering team possible.
Assuming the AI doesn't lead them all off a cliff.
You're worried about developers acting passively, but the material shows that when understanding is no longer the primary bottleneck, developers actually focus on high-value strategic logic. They aren't turning their brains off. They are finally able to use their brains for engineering rather than archaeology.
Archaeology is exactly what is required when you are dealing with artifacts from a bygone era, which is precisely what enterprise legacy code is.
It doesn't have to be, though.
The text says that teams shouldn't accept friction as an inherent part of the process. And, I agree with that sentiment. But there is a massive difference between removing manual processes, like typing out boilerplate setup code, and attempting to automate the extraction of meaning from a chaotic, organically grown system.
So what's your solution then?
If we truly want to solve the productivity paradox, we need to do the hard work of rewriting and refactoring the legacy systems into modern architectures, not just put a highly efficient, AI-driven reading layer on top of a mess.
But we just agreed rewriting takes 2 years and fails.
I didn't say it was easy. I said it was necessary. Because ultimately, when the system breaks under the weight of an edge case, and it will break, the AI cannot take responsibility for fixing it. A human engineer is going to have to step in.
And they will, armed with AI diagnostics.
And if that human engineer has spent the last 2 years relying on a dashboard to tell them how the system works, they will be utterly lost when that dashboard goes blind.
But as we touched on earlier, refactoring a massive enterprise system from scratch is a luxury most businesses simply cannot afford. It takes years and halts all competitive product development.
So we just bandage it forever?
The material frames this AI infrastructure not as a temporary band-aid, but as a strategic advantage. It shifts the entire organization from being operationally reactive to strategically proactive. By surfacing the right information at exactly the right time, we allow developers to move with confidence instead of hesitation.
And I will maintain that confidence is incredibly dangerous when it is unearned. The text states that unmanaged complexity is what slows teams down.
Exactly.
I agree completely, but relying on an AI algorithm to manage your complexity for you doesn't make the actual complexity go away. It just hides the sharp edges behind a very clean user interface.
Well, it seems we are arriving at the core philosophical divide in how we view the future of software engineering. To summarize my position, ending the productivity paradox requires us to recognize the biological limits of our developers.
Which I acknowledge exist.
Right.
Human memory is an unscalable medium for managing enterprise complexity. The low productivity in legacy environments is a structural problem, a tax on working memory, that can only be solved by AI-driven visibility, automated documentation, and instant contextual knowledge. By reducing that overwhelming cognitive load, we finally free developers to do what they do best, which is build.
And my position remains that while legacy environments are undeniably chaotic, punishing, and frustrating, treating deep system comprehension as a mere inefficiency to be automated away is a profound mistake.
Even if it costs 17 hours a week, especially then. The friction of that discovery phase is the crucible where mastery is forged. Relying on AI to abstract away that complexity risks creating a generation of developers who are entirely disconnected from the very systems they are tasked with maintaining, accelerating technical debt under the guise of efficiency.
Well, despite our very different approaches to the solution, it is clear we both agree on the severity of the diagnosis. The productivity paradox is a very real, very painful phenomenon.
Oh, absolutely.
Development teams are not inherently slow, and they aren't lacking in talent. They are being actively crushed by the structural friction, the invisible complexity, and the profound cognitive fatigue that these legacy systems generate.
I couldn't agree more. The misalignment between perceived productivity and actual execution is a systemic failure. Acknowledging that the current environment actively punishes speed is really the necessary first step for any engineering leader trying to navigate this space.
It's a fascinating balance to strike, leveraging powerful new semantic AI technologies to reduce cognitive load while ensuring we maintain the rigorous human oversight and architectural understanding necessary for safe software engineering.
It's definitely the tightrope we're all walking right now.
The Code Aura analysis offers a truly compelling glimpse into the future of development infrastructure. It leaves us to consider a critical question. As we stare down those tangled wires in the metaphorical server room, does true clarity come from an AI assistant that instantly traces the connections for us? Or does it only come from the hard, manual work of untangling the cables ourselves?